Alright, so problem 511. This is similar to 513 in the textbook. We've got a lot of information here. We're told that we have a sample of propane gas, we've got a pressure, a temperature, and a volume, we've got a mixture of oxygen gas with a pressure, a temperature, and a volume, and then the mixture was ignited to form carbon dioxide and water. Alright, I see reactants, I see products. Probably going to need to write a balanced reaction. Well, then we want to calculate the volume of carbon dioxide formed at 250 atmospheres and a temperature of 100 Celsius. So another pressure and temperature. So, propane is C3H8. If that's all you needed, go ahead and write your balanced equation. My balanced equation looks like this. Sorry for the camera. C3H8 plus O2 gives me CO2 and H2O. Next thing, gotta balance it. C3H8, 5O2, 3CO2, 4H2O. Now I've got a balanced equation. I've got some information that I'm going to write down. I've got a volume, a temperature, pressure, volume, temperature, pressure, and I've got a temperature and a pressure. Noting that thing called the ideal gas law, I can take what I have, solve that, and I can figure out moles. Moles are going to be useful because that's going to allow me to get between things. So I rearrange the ideal gas law, N equals PV over RT. I did not substitute values. Why? Because it's 7:33 right now this morning. But I have confidence you can do that. So now I have moles. I have moles of each of these reactants. I want to know how much product I form. If you click through the PowerPoint, you might have noticed, oh, it's a limiting reagent problem. That means I need to figure out how much of each I have. So, I take that 3.11 moles of propane, use my mole ratio with oxygen, and I get 1.555 moles of oxygen. I only had 1.04 moles. Not enough. So oxygen is my limiting reagent. Which means I use that limiting reagent to calculate how many moles of carbon dioxide is produced. Now I'm close. If I look up here, I don't have a volume, but that's what I'm looking for. I have a temperature, I have a pressure, and now I have moles. So I utilize the ideal gas law again, solve for volume, substitute in those values. The R value I'll use here is the 0.08206, and I get 7.64 atmospheres, which is my answer.